Hey everyone. In today's lesson, we're going to be talking about mathematical properties. So, what are the different mathematical properties that you can possibly use to be able to justify solving a linear equation? So, by now, you should have already gone through basically the basic steps of solving a linear equation. Now, what we're going to be concentrating on is justifying each step, which is basically like what are the actual steps that you can possibly do to solve a linear equation. So we're going to be focusing today on the mathematical properties, and those mathematical properties are for the means of justification, meaning like to be able to justify what you did. Yes, it is more work. Yes, it's going to take longer to do the problems because you're going to have to write, but get over it. It's basically just doing stuff that you already know how to do. You're just learning the basic terminology of it. So first thing is the distributive property. What the distributive property is, it's basically parentheses between numbers gets treated like a dot, which means that you have to multiply. So when you do distributive property, you basically are multiplying everything on the inside by a term on the outside. So any term outside of parentheses gets multiplied to every term inside of it. For example, really quick, if you have 2 on the outside and if you have x plus 5, then every single thing, what this means is that the 2 is multiplied by everything inside the parentheses, which means that the 2 is multiplied by the x, but also by the 5. So everything gets multiplied by the 2, which means that when you do the distributive property, you're going to be left with 2 times x, which is 2x. Again, they don't write a little dot in the middle, but it's there. That means 2 times x. And then plus 2 times 5, which gives you 10. So the final answer for this would be 2x plus 10. That would be the distributive property, which you should know by now. So next thing you could do to justify is called combining like terms. So combining like terms means that you can add or subtract any terms as you would any integers or any numbers, positive or negative, as long as they share the same variables and exponents. For example, I can have x squared. Let's make this a 5x squared. So 5x squared plus 4x squared. These are considered like terms because they both share the same variable and the same power. And you would treat this like any other number. It's like saying 5 bananas plus 4 bananas gives you 9 bananas. In this case, 5x squared plus 4x squared gives you 9x squares, or 9x to the power of 2. So all you're doing is combining like terms, which means everything that has the same power and variable, you put it together. So that would be the answer for that. Another quick example, let's say you have like 2x plus y plus 5y, something like that. The 2x does not have any other like terms, meaning like any other numbers with the same variable, but the y's do. Here I have a 1y, or a 1 in front of the y. There's always a 1 there, even though they don't write it. So the 2x just goes along for the ride. You would just have the answer as 2x, and then 1y plus 5y would be total of 6y. So this will be plus 6y. So the final answer would be 2x plus 6y. Don't feel the need that you have to get a single answer or something that's smaller. If they're not like terms, then you can't really simplify it. So big deal, you're done. You don't have to worry about making it more simple if you honestly can. So the next thing is a commutative property of addition. Commutative means that you can move the order of the terms around and it will not affect the outcome. So, which means basically this. So if you have 2 plus 5, which would give you 7, what would happen if I switch the order now? If I switch this and this, if I said that this is now 5 plus 2, would that change the result? Well, absolutely not, right? So the commutative property means that you can move stuff around and it would not make a difference. Again, I can actually add like terms to this. So instead of it being 5, I'm going to say, let's say this is 5 x, and let's say instead of 2, this is 2x. 5x plus 2x would give you 7x. So kind of like the whole combining like terms still applies. So commutative property means you can move stuff around and it would not change the outcome, right? So commutative property, this is a commutative property of addition. However, there is also a commutative property for multiplication, which we're going to go over right now. So commutative means to move, that you can move stuff around and it would not make a difference. For that reason, also, if you have multiplication, 2 multiplied by 3, that would give you 6. If I change the order of that, if I just flip these around, if I say 3 multiplied by 2, that would also be 6. So all that means is that you can move this around and it would not make a difference. So the commutative property means that you can move stuff around and it would not change the outcome. Okay, now I'm putting dots here, but you could easily have these swapped out for like parentheses, because parentheses also mean multiplication, right? So if you guys have parentheses here and there, parentheses there and there, that also means multiplication, but it still applies. 2 times 3 is 6, 3 times 2 is 6. Does not change the outcome. So commutative property means you can move stuff around. The associative property means you can associate or group added terms any way you want and it would not change the outcome. In this case, we're looking at the associative property of addition, which means that we're going to be adding some stuff. All that means is that if we group stuff together like 2 plus 3 plus 4, we can associate or group these any way we want and it would not change the outcome. For example, let's say we want to group these two together, right? So 2 plus 3, that would give me a 5. And then we add that to the 4. Let me go back and change the color on this. Then we're going to add that to the 4, and we get the outcome of 9, right? So that's totally possible, totally legal. However, we could also do that the other way, right? So we got 9 initially. Let's say I did not want to group these two together. Let's say I wanted to group the 4 and the 3. So 2, I'm not going to do anything with that, but I'm going to group together the 3 and the 4, which is going to give me a positive 7. And 7 plus 2 or 2 plus 7 will still give me the same result of 9. So it doesn't matter which way you group them or associate them, it will give you the same outcome. That is the associative property of addition, because in this case, we are actually adding stuff, right? So associative property of addition. So there's also an associative property, though, of multiplication, which basically says the exact same thing. So for associative property of multiplication, it means that you can group anything you want that's multiplied together in any order you want, and it will not change the outcome. For example, going back to my earlier example, let's say I have 2 multiplied by 3 multiplied by, I don't know, let's say 5. If I wanted to group these together in any way that I want, let's say I wanted to group the 2 and the 3 together, 2 times 3 would give me a total of 6. And then I have to multiply this by 5 to get my final answer, which would give me 30, right? So the final answer is 30. But let's say I wanted to group them a different way. Let's say instead of starting grouping the 2 and the 3, I want to group the 3 and the 5. So that would give me 2 would drop down, right? 5 times 3 would give me 15. And then 15 times 2 would give me 30. So the outcome did not change. If you remember from the beginning, the last answer was also 30. So the order doesn't matter. That's all that means. You can group stuff together whichever way you want, as long as they're all multiplied together, and the answer won't matter. Okay? So that is the associative property of multiplication. The additive identity property, a lot of these other ones you probably already know. The additive identity property says that for something to remain the same, so identity means that in mathematics, something that remains the same, it keeps identity, right? So when you get your ID, that's still you. You don't give someone else a picture of somebody else, right? So so the identity means that something remains the same. What do you add to something for it to remain the same? So this is key here. What do you add to something, because this is the additive, right? So we're trying to figure out what do you add to something for it to remain the same. And the answer for that is 0, right? So it doesn't matter what you get, 5, 10, or 20. If you add something and it remains the same, that something has to be 0. Because if you add 0 to any of these numbers or any number at all, it will remain the same, or i.e., it will keep its identity. In mathematics, that's what we usually say. So the additive identity property says that you can add 0 to any number and it will stay the same. Okay, we also have a multiplicative identity property, which means the same idea. Basically means like in order for that number to remain the same, what do you add to it? So what would I add to something? Or I'm sorry, we're not talking about adding anymore for this case. We're talking about multiplication. So what do you multiply to something for it to remain the same? So again, same idea, right? So let's say we have 5, 10, and 20. What can I multiply to those numbers for it to remain the same? That answer is the number 1. If I multiply the number 1 to any of these numbers, or any number at all, doesn't matter what that number is, big or small, the number will remain the same. That means it will retain its identity. So The multiplicative identity property says that you can multiply any number by 1 and it will stay the same. It will remain the same or keep its identity. Okay, we're almost there. So the additive inverse property, so now we're looking at inverse. Inverse is just a fancy way in mathematics to say opposite. So when you're looking at the inverse of something, you're looking at the opposite of something. So in mathematics, when we say opposite, when two opposites, usually we say that they cancel. So when you have two opposites, those two opposites cancel out. So that's where we bring that magic word in of canceling. And then what remains after cancellation? So we're talking about additive inverse property. So what would you add to something that would cause it to cancel out? So for example, I'm going to bring back those three numbers, 5, 10, and 20. What would I add to this 5 for it to cancel out? Some of you guys are ahead of me. So that answer would be a negative 5. So the opposite or the inverse of 5 is negative 5. The inverse of 10 is negative 10. And the inverse of 20 or opposite of 20 is negative 20. So that would cause these numbers to cancel out. And the result would give me 0 whenever I cancel them out when it's in terms of addition. So the additive inverse property says that you could always add the opposite of a number or the inverse of a number and it would give you 0. All right, so some of these are intuitive because you guys have used them a lot in the past. You just probably may not know what the actual properties are called. So that's what this lesson is all about. The multiplicative property of 0 says that any number multiplied by 0, regardless of big or small, is 0. Wait a minute, did I skip one? Oh yeah, I skipped one, I'm sorry. I skipped the multiplicative inverse property. Multiplicative inverse property is the same. So we're trying to figure out what is the opposite that will cause that number to cancel. And then what remains after cancellation. So if I bring back my three numbers, but this time we're looking at multiplication, right? So let's say I bring back numbers like 5, 10, and 20. If I want to multiply something by that 5, or I can actually do parentheses just to switch it up. If I want to multiply something by that 10, and if I want to multiply something by that 20, what would cause this to cancel out? So in terms of multiplication, something that will cause it to cancel out would be a fraction. So in this case, the opposite of 5 would be 1 over 5, which is the inverse, right? We're looking at the word inverse here in mathematics of 5. The opposite of 10 is 1 over 10, which is the inverse of 10. And the opposite of 20 in terms of multiplication is 1 over 20 because it is the inverse of 20. Why is it called the inverse of multiplicative inverse? In this case, because they will cancel out. Some of you guys did this in the past. Basically, the 5 and the 5 cancel because it's on top and on the bottom of this fraction. The 10 and the 10 cancel because it's on top and on the bottom of this fraction. And the 20 and 20 cancel because it's also on top and bottom of this fraction. But the question is, what remains after cancellation? And the answer to that is just the number 1. So as opposed to the additive inverse property where you got the answer to be 0, when you cancel stuff out and when you multiply, when you cancel stuff out, you get the answer to be 1. And that is the multiplicative inverse property. Okay, the multiplicative property of 0, this one's easy. Any number multiplied by 0 will give you 0, regardless of how big or small it is. So it doesn't matter how big or small it is, 500, 50, 1 million, 1,000, whatever the number is, no matter how big or small it is, if you take that number and you multiply that number by the value of 0, so this is 0, 0, 0. Considering this is multiplication, the answer will always be 0. Anything multiplied by 0 will give you the answer to be 0 every single time. That is the multiplicative property of 0. Now let's talk about the additive property of 0. So the additive property of 0 says that any number added to the number 0, regardless of how big or small it is, would give you what number? And some of you guys, like I said, you guys have used this already in the past. You probably just don't know what it's called officially in mathematics. So this is called the additive property of 0. And that means that the number doesn't change. This is also known as the additive identity property because the number remains the same, right? It keeps its identity. So kind of like going back to what we talked about earlier, this is additive identity, but this is also the additive property of 0. Sometimes they'll give you one, sometimes they'll give you the other. If you have to justify yourself, you can just pick your favorite. So this is the additive property of 0. Okay, so let's do some examples. All you have to do for this is look at the problem, figure out what they did, and write it down on the right-hand side. For example, they give you the steps on the left-hand side. You have to justify or give the reasons of why they solved it on the right-hand side. Okay, so let's look at the first step. So the first step, they give you 3 parentheses, x minus 2 plus 5x is equal to 9x minus 24. As you can see here on the left-hand side, what they did is now they got all of a sudden 3x minus 6. Upon inspection, you can see that the only way for them to get 3x minus 6 is for them to multiply 3 times x and 3 times negative 2, which means that they use the distributive property. Distributive property. So that is the very first step. Okay, now let's look at what they did on the second step. So this is what they changed. So we got 3x minus 6 is equal to 5x plus 9x minus 24. And it looks like the only thing that I still see the same exact thing. The only thing that happened is that this negative 6 plus 5x, all of a sudden, they switched it into 5x minus 6. So they switched the order. Or in other words, they moved them. What is the property in which you can move stuff around? That is called the commutative, because they moved it, property. Now, if you notice, they moved it, but they were adding it initially, right? So I'm going to add here of addition. Sorry that it doesn't fit very well, but I read really big, so big one. The next step, okay, let's see. They got 3x plus 5x, and then all of a sudden that turned into an 8x. Everything else stayed the same pretty much. Negative 6 is still there. All the other stuff is still there. So what I can see upon inspection is that the 3x and the 5x turn into 8x, which means that they combine like terms. So this is called combining like terms. Okay, now on the next step, so that 8x is still there, the negative 6 is still there, the 9x is still there, the negative 24 is still there, but for some reason, all of a sudden, out of nowhere, they subtracted 8x to both sides, right? So when they subtract the same thing to both sides, add the same thing to both sides, divide the same thing to both sides, or multiply the same thing to both sides, that is the property of equality, depending on what they did. In this case, they subtracted to both sides, so this is called the subtraction property of equality, which is just a fancy way of saying did it to both sides. So you can add here any other thing: addition property of equality, multiplication property of equality, division property of equality. That just means that they did it to both sides. Okay, nothing fancy. Now on the next step, they have 8x minus 8x, and then 8x minus 8x turn into 0, which means that it canceled out. Canceled out. Whenever you see the word cancel, think of inverse. So this is the inverse. So some inverse property. Inverse property of what? Did they multiply or did they add? As you can see, 8x minus 8x, they added a negative number and they canceled it out. So this is actually the additive inverse property on the left-hand side. But some other stuff changed on the right-hand side too. As you can see on the right-hand side, the 9x and the 8x, they subtracted those two and they got only 1x. So let me write left, or yeah, I'm going to try to squeeze left here. So the left side, they canceled it out, which means they did the additive inverse property. So additive inverse property. On the right-hand side, all they did was combine like terms, right? They put the 9x minus 8x and turned it into 1x. So combine like terms. Okay, moving on. Like I said, these problems take longer because you have to justify, but a lot of the times they already give you the work. So what happened here? So we have 0 minus 6 just became negative 6. The 0 is gone, disappeared. So what does that mean? When the number doesn't change, it keeps its identity. So when the number keeps its identity and it doesn't change, this is called the identity property of what? In this case, this is the additive identity. So additive identity property, because the number remained the same. Basically, you add 0, nothing changes, so it's identity. All right, so let's see what else they did. So the next thing they did is they added 24 to both sides. Everything else stayed the same, right? -6 is still there, x is still there, -24 is still there. But for some reason, they added 24 to both sides. So whenever they do that to both sides, remember that it's of equality. So this is going to be added to both sides, which means it's going to be the addition property of equality. All right, so next up, what they did is they got a -24 and they got a +24, and then all of a sudden they switched that to 0 on the right-hand side, which means that it canceled, right? On the left-hand side, they got a -6 and a +24, and they turned that into an 18. So on the left-hand side, they basically just combined like terms. While on the right-hand side, they canceled it out, so they did an inverse property, in this case, an additive inverse property. So I'm going to go ahead and do the same thing as last time. On the left-hand side, they combine like terms. Combine like terms. On the right-hand side, it canceled out and they did an additive cancellation. So it's additive inverse. Additive inverse property. Okay, and then finally, last but not least, I promise you there's only 2 examples. This is 1 out of the 2. Last but not least, they said, okay, x plus nothing equals just x, meaning that that number stayed, that x, whatever that number was, remained the same. So it kept its identity, right? So once again, we have additive identity property. So additive identity property. And there you go. So like I said, all you have to do is justify the steps. A lot of the time they're going to give you this side, they're going to give you the left-hand side, all the steps, and you're going to basically justify them on the right-hand side. Sometimes you have to do this by hand, like from scratch. Or if you're doing it on the computer, they may have you like drag and drop some stuff in there, like fill in the blanks. And they'll give you like a menu of all these different options that you possibly can have. So to guide you a little bit. This one is much longer. Like I said, there's only 2 examples because one of them is really, really long. But now that we did one example, we can probably go a little bit faster. So first thing we need to do, figure out that this and this is multiplied to be able to get 3x minus 6. So that is called the distributive property. So distributive, can't spell, property. Thank God I'm a math teacher. So then we have 3x plus 5x. 3x plus 5x. Oh, wait, I'm sorry. I skipped something. That's not what they did. What they did is they got the -6 and the 5x, and they switched the order to 5x minus 6. Everything else, if you notice, remained the same. So when they switched the order, they moved it. So this is called the commutative, because they moved it, property. And this is the commutative property of addition, because they basically moved stuff that was added together. All right, so then what did they do? As you can see here, it looks like they basically did the opposite of distributive property. So I'm just going to put here distributive property in reverse, right? So basically, instead of like multiplying it in, they took stuff out. So distributive property, there's actually a name for this, but you're not going to get to that name until probably Math 2, so we'll just call it distributive property in reverse. Next, what they did is they converted the 3 and the 5 into an 8. So 3 plus 5 would give you 8, or 3x plus 5x is going to give you 8x. This is just basic addition. Or you could have also said combine like terms. I'm going to leave it as basic addition. Even though if you would say combine like terms, I would also mark that completely right, because the 3 and the 5 are like terms. Okay, then what they did is they multiplied these two. X times 8 is equal to 8x. So all they did was move the order, right? The 8 was in the back, and now all of a sudden it's in the front, but it's still 8 times x. X times 8, 8 times x, same thing. So they moved it. That is the commutative property, but this time it was multiplied. So I'm going to say of multiplication, right? Because in this case, they move stuff around, like 2 times x equals x times 2, or 2 times 3 equals 3 times 2. Same thing in this time, x times 8, 8 times x, same thing. All right, almost there. So 8x minus 8x. So it looks like what they did. Oh, I see what they did. Okay, so they, out of nowhere, subtracted 8x to both sides. Everything else stayed the same. So minus 24 remained the same. 9x stayed the same. Negative 6 stayed the same. It looks like they subtracted 8x to both sides. So that is a subtraction property of equality because they did it to both sides. Equality. There we go. Next, let's see. Dang, they did some extra steps here. But anyways, we can manage. So they did the same thing here. So basically, they took the x and did a distributive property in reverse to both sides. So distributive property in reverse. Then it looks like they did 8 minus 8 here and they got 0, and 9 minus 8 here and they got 1. So it seems to me like all they did was add or combine like terms. Like I said, if you want to do addition or combine like terms, either way you want to, however you want to word that, that would be fine. But something special on the left-hand side though is that the 8 minus 8 actually cancel, right? So it's called canceling because it gives them a 0. So on the left-hand side, I'm actually going to write left additive inverse property, because in this case, these numbers canceled. So they're inverses of each other. On the right-hand side, these numbers did not cancel, right? 9 minus 8 gave you 1, which means that since they didn't cancel, they basically just added them or subtracted them on the right-hand side to be more precise. So on the right-hand side, right, they basically subtracted or subtraction. Okay, I'm doing really hard ones, by the way. The stuff that you're gonna get on your on the actual work won't be as hard as this, but I want to give you like the hardest that it can possibly be to not, to explain everything fully. Next thing, okay, so they said that x times 0 gave you 0, and on the right hand side, x times 1 gives you x. On the left hand side, x times 0 gives you 0. That is a property. That is a 0 property of multiplication, meaning that everything multiplied by 0 will give you 0. So on the left, I'm going to write 0 property of multiplication, because anything multiplied by 0 will give you the answer of 0. On the right hand side, it's a little bit different because you're multiplying by 1, and that whatever you multiply by 1 stays the same. Staying the same in mathematics means identity, right? So if you remember from the rules before, so that means that since you're multiplying something to remain the same, it's the multiplicative identity property, which means that you multiply by 1, anything multiplied by 1 stays the same. Okay, so lo and behold, down to the last couple. So next we have 0 minus 6 gives you negative 6. That is a property that says that if you add anything, or if you add 0 to anything, then it remains the same, right? That negative 6 did not change. So this is called the additive identity property, meaning that if you add 0 to any number, it will remain the same or keep its identity. Okay, so next up, let's see what they did. Oh, I see it now. They added 24 to both sides. So this is basically the addition. Key is both sides. Property of equality. And the properties of equality means whatever you do to one side, you do it to the other side. Okay, next up we have this. Negative 6 plus 24 gives you 18. And on the right-hand side, negative 24 plus 24 cancels out and you get 0. So it's a little bit different, right? On the left-hand side, all we did was add or combine like terms. So left, we just addition or combine like terms. Either way, I'd mark that right. On the right-hand side, it looks like stuff canceled because you got a 0 left over, right? So when something cancels, it is its inverse. So this is actually the additive inverse of 24. So negative 24 plus 24 gives you 0, cancels out. So therefore, it is the inverse. And finally, last but not least, 0 plus any number will keep the number the same. That's all that happened here, right? So x plus nothing gives you that same thing because you're not adding anything. So this is identity because the number did not change. So this is called the additive identity property. Whew. So there you go. There you have it. You have been mind blown. Yes, it is a lot of writing, but you're going to have to do this when it comes to the aspects. So just suck it up, learn the properties, and get it done. See you guys on the next one.